Hello and welcome to our virtual information session for the College of Engineering at the University of Arizona. My name is Leslie Grignon. I'm the coordinator for recruitment and student engagement for the college. A lot of what I do is work with students and families throughout their college search process, particularly for the College of Engineering at the U of A. I want to preface this info session by letting you know that you can easily reach us via phone or email or Zoom if you have more questions, maybe after watching this presentation or something that you would like to chat more in depth about. So get in touch with us. The easiest way is via email. You can email us at engr-admissions@arizona.edu. I like to preface this info session to start by letting you know it's kind of like a story. We start with when students apply and we end with when they graduate, and everything in between are experiences and opportunities that they can take advantage of throughout their time here as engineering students. So let's go ahead and get started. We will start with how to apply. If you're an admitted student, you can pat yourself on the back. You've already done this. So number one, complete the online application. You can apply through the U of A directly, or you can apply through the common application or the coalition application. You can choose whatever platform works best for you. You're going to want to specify engineering, no major selected, as your first choice major. That will allow us in the college to review your application on top of the UA admissions office. Number three, self-reporting your grades, which means that you'll manually type out all of the courses that you've taken freshman through junior year, and then also indicate the classes that you plan to take in your senior year. We call those your in-progress courses. And number four is send in an ACT or an SAT score. The university does not have a preference on which exam you send. We will give you the maximum base merit scholarship based on your GPA, so number three, and number four, your test scores. You can go online and see a really transparent grid of how much money you will be looking at from the university, renewable for 4 years under scholarship guidelines through your grades and also your test scores. So when you say you want to major in engineering, here are some of the criteria that we are looking at. Math and science preparedness is at the utmost importance for engineering students. So we ideally would like our students to start at a Calculus 1 level, which means when we're evaluating students, we'd like to see what kind of courses you've chosen to take in high school, particularly in math and science. So during your senior year, those courses are important. We want to see what kind of math and science you've decided to take. Hopefully something along the lines of pre-calculus or calculus, putting you on the track to taking Calculus 1 as a new student at the U of A. We'll look at any rigor that you have in your schedule. So those are AP classes, honors, dual enrollment. We also understand that not every single high school is going to have that curriculum, and that's okay. If you have rigorous courses, we definitely will look at them and see how they're preparing you in that way. We're obviously going to look at your core unweighted GPA, and we will also look at your ACT and SAT scores. And of course, we will read any optional information that you send. That could be an extracurricular resume or a personal statement. Here are some facts and figures about the college. Up top, you will see the averages of admitted students. These are averages. These are not minimums. I like to stress that a lot. Not every single student is going to have these exact metrics. But to give you an idea of who our students were in terms of unweighted GPA and test scores, you can see up top reflected, those are the averages. In terms of our student community, the University of Arizona is a large institution. So we have 35,000 undergraduate students that attend the U of A. In terms of the College of Engineering, for new freshmen, we have between 600 and 650, give or take, students each year to come and study engineering, and that splits out into about 15 different degree programs. So our college community, in my opinion, is a really nice size. We are not teeny tiny, but we are not very, very large. So what that means is that you get to know your faculty, staff, and peers really well, but you're at a large institution. So the U of A, we are a Division I school in the Pac-12. We are a Tier 1 research institution. We have over 200 different degree programs for students to study, and we're on 1 square mile of campus in beautiful Tucson, Arizona. So you have a really fun backdrop landscape playground as your university, but your college is small. And so you have that nice communal feeling and support system, which is a nice juxtaposition. About 40% of our students are out of state. So we have students coming from all over the country and the world to study engineering here with us. About 30% are women, which we are very proud of. That's about double the national average. Our retention rate is amongst the highest for colleges at the U of A. Last year was about 91%. So we are very proud of that. I think we attribute a lot to that, to the community that we build, particularly with our students in the first year. So a big logistical piece to keep in mind, if you're an admitted student, you probably already know this, and it's good to keep in mind while you are applying. All students will apply as engineering, no major selected. So what that means is no student is coming in with a specific major in the College of Engineering. The reason we do that is we have 15 different majors, and I'm sure on the next slide there are some majors that you might not know about or that you haven't heard about, or you might not know what jobs are associated with them. So we have all students come in as no major selected engineering students. They all take a course called Engineering 102, which I will tell you about in a few slides, and then they can declare whatever major they want, really on their own timeline. So we don't have caps or quotas or competitive entry into any of our programs. So what that means is we don't only have X amount of seats in X program. Students can declare whatever major they want. They are not competing with the person next to them for a limited amount of seats in a major or a department. So this is really designed with the students in mind. It's designed for them to make an educated decision about their choice of major, and for them to feel comfortable and confident moving into a major and not just choosing one based off of knowledge that they've accrued from some other place. So that's how it works. We love this flexibility for our students, and our students really enjoy it too. So we have 15 different majors on this list here. I definitely won't talk about all of them. I'm sure that would be boring for everybody. But among some of our popular majors, we have electrical and computer engineering for folks who enjoy hardware, software, coding, circuits, telecommunication, mechanical and aerospace engineering for students who want to study and optimize systems of motion, either on the ground, mechanical, or in flight, aerospace. So if you're interested, we have a supersonic wind tunnel in our aerospace and mechanical engineering building, which goes anywhere between 3 and 5 times the speed of sound. This is pretty neat. Biomedical engineering is great for students who are interested in the human anatomy, physiology, biosensors, biomaterials, pharmaceuticals, prosthetic limbs, things like that. Civil and architectural engineering, great for students who are interested in transportation systems, construction management, horizontal and vertical construction of things like bridges, buildings. Architectural engineering is great if you want definitely more of the infusion of design that you would get from a traditional architecture degree. Very popular among students. It's actually our newest major. We have optical sciences, which is one of the few undergraduate programs in the US. If you're interested in studying and manipulating light, optical sciences is a great program. They build imaging systems, cameras, lenses, and some of the largest mirrors in the world underneath our football stadium. We have mining engineering, which actually was the first major. All the other majors kind of fell after mining, which is pretty neat. Mining's been around for a very long time. It's a big part of the history of our college and our state. So mining is the art of extracting mineral from the earth. So we actually have a student-run mine about an hour south of campus, one of the few in the country. Students can study mine operations, reclamation, sustainability, things like that. So really cool major. And if you think about all the things that we can't grow naturally, we do have to mine them. Biosystems engineering is great for students who are interested in cleaning up water, clean food, alternative energies, lots of jobs across lots of various different fields there. Chemical and environmental engineering for students who want to take raw materials and turn them into consumer goods, or cleaning up air, pollution, water, things like that. We have systems, industrial, and management for students who are interested in managing the life cycle of a project, increasing efficiency, increasing budgets, and working with other personnel. Material science and engineering, students who are interested in playing with glass or polymers and making new materials for different industries, like maybe the aerospace industry, or maybe something else, like the spacesuit was invented by material scientists and engineers. So there are so many different majors for anybody and everybody in engineering. So I guarantee you will find something that you are interested in or that you didn't even know existed, which I think is the most fun and coolest thing about our college. So in terms of the first semester and the first year, you can see everybody's taking very general courses. You can also see why we harp a lot on that Calculus 1 preparedness. All of our degree programs are meant to be done in 4 years. Calculus 1 is kind of the key. It is the key to all of the other engineering courses. So that's why we would like you to start at a Calculus 1 level so you can move forward with the math and the science and the engineering specific coursework from there. If you're a student who is admitted, when you come to orientation, we will make you a schedule. That's our priorities, to have you enrolled in classes that you feel good about. If you have AP credit or dual enrollment credit, or you don't have any credit at all, we will figure out where you are in terms of placement. So don't worry about choosing your classes. We will help you through that, especially for that first semester. You can see Engineering 102 is on there as well, which I will tell you about in these next couple of slides. So Engineering 102 is made up of 2 parts. We have a lecture and the lab. The lecture is kind of like a TED Talk series. It's once a week for 1 hour. All of the students will sit and listen to different department representatives talk about their major of study in their field. So the different representatives come in and they tell the students about what their major, what kind of classes you might take, what kind of research opportunities are available, what kind of companies want to hire you, what kind of big engineering grand challenges might that particular person who's studying that field solve. We also have students work on their resume and go to the career fair. This is definitely not meant to intimidate students. It is meant to help them feel comfortable to go to the career fair and make those connections with recruiters and really start to open up their eyes to what that process is. At the end of this semester, towards the end, students actually go to open houses for the different departments. They get to choose departments and mingle with their staff, their faculty, department heads, students, etc. And hopefully solidify what major department they think that they would fit really well in. Students by no means have to declare on the last day of class in Engineering 102. About half of them will declare after that first semester, and students will kind of declare as they feel confident moving through that first year. They also will take a lab portion of Engineering 102, which is a smaller course. It's about 30 students. It's supposed to be an intro to design and teamwork. The notable project of Engineering 102 lab is the solar oven. So students will build a solar oven in groups of about 4 to 6. They'll receive materials like cardboard, tinfoil, duct tape, and they'll design a t-shirt that they vote on. So you can see that was a couple of years ago, kind of a retro vibe. And students actually will model their oven and create an Excel prediction about how hot they think their oven will get. And then on our biannual event called the Solar Oven Throwdown, they will bring their solar ovens, go out onto the mall in the hot Arizona sun, and we'll give them a raw biscuit or cookie, and they will bake it together and figure out whose Excel prediction was the most accurate. And they usually win a Frisbee or something fun, the winning team. So it's kind of an intro in working together on a team, designing of an experiment, and creating something from the beginning to the end. So it's our 102 curriculum. We're very proud of it. We think it really embeds students in our community and helps them feel connected to each other and also connected to the field of engineering. Moving on to housing, we hope you want to live on campus. The majority of new students do live on campus. If you don't know where to live on campus or you're looking for some recommendations, we highly recommend looking into themed communities. Themed communities are usually a floor within a dorm of students who opt in to living together. Usually they share a major or an interest. And so as you can imagine, these students connect really well together because they have similar goals, they're interested in similar things, and they become friends really quickly because they might be in the same classes. So it's a good way to ensure a happy and healthy living community for you during that first year. So the first one is the Engineering Leadership Community, the ELC. This is open to engineering students. It will be in Yuma Hall in the fall of 2020. I love Yuma. It's a great location. It's in the historic district. So if you go on the virtual tour through UA admissions or on the campus map, you can see it's very, very close to the engineering building, which is where we are. The students take a success course where they start to learn about how to craft their resume, how to get involved outside of the classroom and be a leader in their community. Students also get to take part in curated activities like resume workshops, field trips, and different professional development events. So they're getting a lot more out of their living community than they might just get living in another dorm. They're getting engineering specific opportunities that are made for them to succeed. So that's the engineering leadership community, all the same students in the same classes. I've had some really great groups of friends come out of the ELC over the years. So we've had a lot of great student leaders live in this community. The second one is CAMBIUM. It's actually a partnership we have at the Honors College. So students do have to be admitted into the Honors College to live in the Honors Village, as well as to be a member of the CAMBIUM STEM Scholars community. CAMBIUM is a little bit wider of a net. It's not just engineering students, it is STEM students as a whole. So if you are an engineering student, but even if you're a computer science student or a biochemistry or geosciences or physics, you can opt into living in this community if you're also a member of the Honors College. This community also has a success course like the ELC, but it is more focused on getting engaged and involved in research. This is paired with the Honors First Year Project, which is an opportunity that honors students can take advantage of to get involved in guided research during their freshman year. They choose a research project prompt, and they actually get faculty mentorship and support throughout that first year. They will then present their project at the Honors First Year Showcase. Over the years, I've had a couple students win like Best in Show for their Honors First Year projects. It's kind of sweet. You win a cash prize and you get a guaranteed research experience during your freshman year. So these two theme communities are available to our engineering students. If you have questions about theme communities, you can definitely get online through the Housing and Residential Life website, learn more about them, or get in touch with us about how to apply. It's through the housing application that you can opt into these communities. They're not required, but they are really fun and awesome. And like I said, we've had some really great students emerge and get really involved after living in these communities. Academic support is a pivotal piece of your transition from high school into college and really throughout your 4 years as a student. So we have plenty of support that students take advantage of, things like Think Tank, which is a campus-wide tutoring service that offers math, science, writing. The Writing Center is fantastic. You can go there for essays and lab reports and things like that. We also have engineering-specific study sessions for those upper division classes like differential equations or vector calculus. I can't stress enough how much I think academic advisors are key to students' success. You will receive a no major selected academic advisor and then also an academic advisor once you declare your major. These folks are the people who want you to succeed. They want you to graduate on your timeline. They want you to get involved in everything that you think is interesting. So seeing your academic advisor is really important, and those are the people that want you to succeed. Also, office hours. A lot of successful students will utilize office hours, which are where faculty are sitting in their office waiting for students to come chat, ask questions about the homework, prepare for exams, or maybe form a relationship to get involved in a research position. So I've seen a lot of successful students go to office hours as a normal part of their routine, and they make good connections with faculty that way. So those are just some of the academic support pieces. Moving on, so things outside of the classroom, you're going to want to get involved in aspects of the campus that aren't just going to class, right? So the first way to do that is to get involved in undergraduate research. We are a Tier 1 research institution, which means the U of A is conducting research at the highest level. Your faculty members are working on research with their graduate students and undergraduate students, so maybe they have a lab on campus and they can invite you and work in that lab. So what that means for you as a student, when you reach out to a faculty member, maybe you enjoyed their class or you've chatted with them about their research, you can work in their lab on a volunteer basis. Some students can do independent studies. Some students can even get paid, so it can be kind of like an on-campus job for them. The neat thing about research is faculty really enjoy having new and younger students getting involved. So I know it can sound intimidating, but do not be nervous to go and talk to a faculty member about getting involved in their research lab. This is a really wonderful thing to put on your resume as you start getting older and thinking about internships and jobs after graduation. Research can open a lot of doors in terms of presenting at conferences. I've had students get published on papers, and I've had students figure out what they really enjoy about their field by working in a research lab. So I highly recommend getting involved as soon as you can, or you find something that piques your interest. Your academic advisor will send out a lot of info about available spots. Clubs are similar to research, great way to get involved and to bulk up your resume. So we have professional societies within the college and design, build, compete clubs as well. Professional societies are usually associated with an identity or a department or major. So if you're a chemical engineering student, you might join AICHE, which is the American Institute of Chemical Engineers. You also might want to join something like SWE, the Society of Women Engineers, or SHIP, the Society of Hispanic Professional Engineers. These are groups that help students professionally develop, go to conferences, hold career fairs. SWE, for example, has Night of Networking, which couples with one of the engineering career fairs. So it's a good way to meet friends, but also to get involved in your professional community. Design, build, compete clubs are where students work on a design project for the entirety of the year together as a team. So pictured on the slide, you can see Baja, they build an off-roading vehicle. We have Formula One, they build a Formula One vehicle. A concrete canoe, popular among civil engineering students. You know, they build a canoe completely out of concrete and they race it. You know, Rube Goldberg, they actually won first in the competition this year, the Rube Goldberg. I think that their mission was to ring a doorbell, which is pretty neat. You can be any kind of major and join these clubs. You don't have to be a mechanical engineering student to join Baja. You could just like tinkering with cars and you can join Baja. So these different teams compete. So it's a great thing to put on your resume, great lessons in working together on completing a project, kind of like Engineering 102, the lab section. So internships are popular amongst our students. A lot of students would like to get an internship in order to ensure that they're going to get a job after they graduate. So A lot of students will do internships either during the academic year, but I would say more popularly over the summer. Summertime allows students to kind of not be on campus if they don't want to be, maybe take an online class or not. Also allows them the flexibility to travel and to get out and to explore the world. A lot of students will get their internships through going to the career fair. It's probably the #1 way that students obtain an internship. So you can see that's why we want students to be comfortable with going to the career fair so they can form relationships with recruiters and see what kind of companies want to hire them. Internships are usually paid. For engineering students. They're doing real work. They're not just getting coffee or making copies. It's kind of like a test run for a full-time job offer, because a lot of students do want to pursue a full-time offer with a company that they've interned for. As you can see on the slide, it's Jessica. She's one of our student ambassadors. She worked at the Imagineering department for Disney, so that was a really neat experience for her, and she had a lot of fun working for them in California over the summer. Here are some examples of where students have gone in the past. We definitely don't want to say that students only go to these companies or only specific places in the country. It's just to give you an idea of where some of the students have gone in the past. I do think it's a cool way to, travel and learn about a different part of the country and get a taste of corporate culture that the students really aren't getting when they're in class. So a lot of these students do these internships over the summer, like I said, during the academic year, some of them too. I think that most pivotal point is between the junior and senior year. A lot of students would like to get a full-time job offer moving into their senior year from their internship they completed that summer prior. I like to point out on the slide as well that students who might not be interested in working in industry post-graduation might want to pursue an REU, which is a research experience for an undergraduate. REUs are internship opportunities where students actually go to another university to conduct research. So if students start to realize that they want to pursue an advanced degree or continue on with academia or research in some way, an REU might lend itself better to their postgraduate goals than maybe doing an internship. But it's all really useful in forming your network and figuring out what you like and what you don't like, which is important. So we have senior design. This is our interdisciplinary capstone course. This is a curricular experience that students will move through during their senior year. So they will actually work on a project on an interdisciplinary team with other students, usually paired with either a corporate sponsor or a university sponsor on a project. So students will actually receive a budget. They will have to figure out what kind of materials they need, purchase their own materials. They create design reviews that they will present to stakeholders and also to their sponsor and their mentor. The sponsor is usually someone from that company or that group who's sponsoring the project. And the mentor is generally someone who wants to stay involved with current students, usually maybe someone retired from industry. So they will have help and guidance along the way. And a lot of the spring semester is spent prototyping and preparing for design day. As you can see, 2019, you can see the design day numbers. Design day is really the best day that we have in our college besides graduation. Our seniors are just so happy and proud of what they've worked so long to create with their teams. We have about $35,000 in industry-sponsored prizes. So it's really neat for our students to win a big cardboard check as they're walking out the door in graduation in a couple of weeks. So you can go on engineeringclinic.com to view some of the projects from this year and also from years past. We've had big companies that sponsor us generously again and again, year after year. Companies like Honeywell or Raytheon or Roche or even PayPal was a sponsor last year. I know one of my students was on a project for them. But we also engage local community sponsors. We have Rolly's Mexican Patio, which is a Mexican restaurant here in Tucson. They're sponsoring a project, as well as things like Mr. Car Wash, which is local to Tucson Car Wash Company. So there's a extremely diverse pool of different projects that students can work on. And really, it's a cherry on top of their experience here in terms of executing and cultivating a team and working on a project from start to finish. So as students move into graduation and into the next phase of their life, about 60 to 75% of them year after year are going to go into industry. And what that means is they go and work directly after they graduate. About a quarter of them will continue on with an advanced degree. That might be an accelerated master's or PhD with us. at the U of A or maybe somewhere else. An accelerated master's is where students can choose to complete a master's in 1 extra year. So in 5 years total, have a bachelor's plus master's in their field of study. Plenty of students go to other institutions around the nation or the world to continue on to. Law school, medical school, also common as well. About 3 to 5% of students will move into maybe civil service, US military, Peace Corps, something like that. I love working with engineering students for so many reasons, but one of my favorite reasons is they do really important work, and a lot of different kinds of companies really look forward to hiring engineers and bringing them on their team to help them solve those really complex grand challenges. I talked about this earlier. We have plenty of career fairs that students can attend that are hosted either by the university or by us within the college, like Industry Expo, which is an engineering specific career fair. It's still the best way students get jobs is making those connections face to face with recruiters and through interviews and things like that. So that's the end of our presentation. I want to thank you for listening and for tuning in for this virtual info session. I want to reiterate what I said earlier about getting in touch with us. If you email us at engr-admissions, that's a very quick way to get a response, and we can set up a Zoom meeting or maybe talk on the phone about other questions that you might have about the college or the process in general. I highly recommend following us on Instagram. That's AZ Engineering. We have a great Instagram feed. It's really fun, and you can really stay connected with what's happening and see see all of our different clubs and events on campus as well. Also follow us on Facebook as well for updates. So we look forward to engaging with you throughout the academic season, and I hope you all have a great day. Thank you for tuning in.